Hello folks, and welcome to Weed Code, where we talk about algorithms and different data structures. Before we start talking about data structures, even the simplest ones such as an array, we actually need to talk about how we store, manipulate, or access the data. And for that we'll need RAM, or random access memory. And it's a type of computer memory that allows quick access to the stored data. So here in RAM, all our variables are going to be stored. So let's have a look at the array that we've got here and how we're going to store it in RAM. First, we need to mention that we measure RAM in bytes. And usually a computer has about 16 gigabytes of RAM, which means that it has about roughly 16 billion bytes of RAM. But what actually is a byte? And you probably know that a byte is a small unit of information that represents a piece of data, and it's made of even smaller units that we call bits. So what is a bit? Basically, bits are the smallest units of information that a computer understands. So it's like a tiny switch that can be either on or off. In other words, it is a position in a computer that can store either a 0 or a 1. So bits form bytes, bytes form kilobytes, megabytes, etc. And this all leads us to RAM that can store more complex data structures. Now, let's actually go back to our array. How we store it in RAM is going to be our main question. Here, we've got integers in our array, and we represent an integer not by 1 byte, but actually by 4 bytes, which means they're going to be 32 bits. And let's take, for example, our very first integer here in the array. And here below you can see how we represent it in bytes. So it's 31 zeros and 1 1. So when we represent an integer in zeros and ones, we can actually put it into RAM. But how do we store information there? That's our next question. So let's imagine a city with many buildings, like that. Each building represents a location in RAM where data can be stored. So the buildings are like containers that can hold different pieces of information, values, such as numbers or words. But each building has also its unique address, like a street address in a city. And when we want to access a specific information, specific data value, we provide this address to the computer. So the computer can then go directly to that building and get the stored data inside and work with it. So values are the actual information stored in the building, and the address helps the computer locate the correct building in the city. When we speak about RAM and how we store arrays there, we speak about a contiguous block of information. And it's like a series of buildings that are located right next to each other in the city. So nothing goes in between, nothing, absolutely. Data is stored in a consecutive manner. If we look at the array that we've got, so we're going to have 1 stored here, and the address is 0. 5 is going to be here, and the address is 4. And 9 is going to be here, and the address is 8. You can ask why the address isn't 0, 1, 2, but is actually 0, 4, 8. But if you get to the beginning of the video, you'll remember that we represent an integer not by 1 byte, but by 4 bytes. So we need to increment our address by 4. 048. But what about characters? What if our array consists of letters instead of integers? And the trick is we also gonna store them contiguously. So we will put them here, but the difference will be the address. If you remember when we talked about integers, the address was 0, then we had 4, and then we had 8. But the difference about the address with characters is that we will be incrementing by 1. So the address will be 0, 1, and 2, because it takes only 1 byte to store a character. I do hope that those examples were useful to you, and now you have a better understanding of how RAM works.